5 or an older version of SQL Server, I would need to use union all. But now with the group by grouping sets keywords, I'm allowed to specify into parentheses pairs of grouping sets. Also, the object dependencies in SQL Server 2008 allow us to accurately track object dependencies with new dynamic management functions. So to this end, we have a new system view and two key DMFs. The system view, in plain words, it displays all the dependencies within a database. The first DMF, that is sysdm SQL reference entities, given an entity, an object, it displays all the other objects, entities referenced by by the given entity. And the opposite of that is the sysdm SQL referencing entities, DMF, which given an entity, it returns all the other entities referencing the entity we used as input. Let's jump to the next demo and see this. So, grouping sets, I'm using the AdventureWorks database. I'm going to perform my grouping on the sales.sales order header table. You can see some sample data here. So the traditional way of having multiple groupings was by using the union all keyword. And in the first subquery, I have customer ID and salesperson ID in the group by clause. In the second subquery, I have customer ID and territory ID in the group by clause. And these two subqueries are connected using union all. So if I execute this script here, you can see that our result contains 38,463 rows. Now, we can also try doing this using the group by grouping sets functionality in SQL Server 2008. So I just use the same query, but in the group by clause I have the grouping sets keywords, and into parentheses I have the pairs of the grouping sets I want to be to perform the grouping on my query. So I have customer ID with salesperson ID, and I also have customer ID with territory ID. So if we execute this, we see that we get the same result, that is 38,463 rows. Now, the object dependencies, I'm not going to use the where clause here. I'm just going to show all the dependencies within the AdventureWorks database. So here you can see the referencing object names, the reference schema names, the reference entity names, and so on. And if you go through all these records, you actually see all the dependencies within the database. Now, more specifically, let's say we want to find all the objects referenced by a given store procedure, that is human resources, USP update, employee, hire info. So I use the sysdm SQL reference entities DMF. I pass as a parameter my store procedure. I say that it is an object. And by executing this, you can see that this store procedure references all these objects. Also, if we want to see all the objects references in given entity, in this example, I want to see all the entities referencing the table dbo.errorlog. I'm using the sysdm SQL referencing entities DMF, passing as a parameter the dbo errorlog table, saying that it's an object. And if I execute it, I see that There is one store procedure called USP log error referencing this table. We can easily double check this by going to the store procedures, the object explorer of the AdventureWorks on the AdventureWorks database, USP log error, the code of the store procedure, and see that it inserts information in the dbo.error log table. So what we saw here, the result returned by the CSDMS SQL referencing at its DMF is correct. Okay, let's continue our presentation. Now I'm going to talk about the hierarchy ID data type. Well, the hierarchy ID data type is a system-supplied CLR UDT. It represents a position in a hierarchy. It uses compact and efficient storage. It provides support for arbitrary and insertions and deletions. And of course, it can be used as a natural representation for organization charts, bill of materials, general ledger accounts, sub-accounts, and so on. Also, the hierarchy ID data type, as a CLR data type, provides significant amount of methods allowing to use it efficiently. So we have the get ancestor, get descendant, get level, get root, is descendant, so on. All these functions assist the user to traverse the hierarchy easily and find nodes. I prepared a demo for the hierarchy ID data type. So I will use the demo DB 2008 again. And now we have to consider the following hierarchical data. So this represents the structure of an information services organization, where we have the CO as the root, let's say, that is the highest management. We have the chief technical architect, customer support leader, which reports to the chief technical architect. We have Nicholas and Clark belonging to the customer support department, that's reporting to the CS leader. And we have the chief software architect reporting to the COO. We also have the IS leader, that is information services leader, reporting to the chief software architect. And we have John and Kate reporting to the IS leader. I have uploaded the diagram here in order to better understand the structure of this company, as we are going to answer questions about this structure using queries. I will just give you 2 minutes to see the hierarchy. Okay. Switching back to SQL Server Management Studio. Okay. So now I'm going to create a demo table and populate it with data. I will call my table hierarchy data. It has 3 columns: employee ID, employee name, and manager ID. And the way I'm using manager ID column is to point to the employee ID in order to try and represent the hierarchy using pointers, let's say. Small initialization. And so here you see that I import this data to my hierarchy table, trying to represent the hierarchy we are saw.